Good morning, Jameson. How are you? Good to see you. Go ahead and get logged into the Nearpod. And then we will, let's see. Let me check it out. Okay, so you're having issues getting into that Nearpod. I'll check it out and see what's going on. Well, I'll fix it after our lesson today. Sound good? Sometimes the linking with the Nearpod, it doesn't work. So I will get that fixed up for you guys. So go ahead and get logged into the Nearpod while we're waiting. We have about 4 minutes still. So you guys are good to chat or ask me questions or whatever you need to do while we're waiting. So today's spell work's pretty simple if you want to get started on that. So we're just talking about our high low. So sometimes we'll do this, not really science related, but we'll talk about share one high and one low, maybe something you learned this week. So while we're waiting for everybody, you guys can get started on that. Or you can also chat with each other too. That's a good way to get to know your classmates. You can stand up. My son wants to say hi to you guys. Oh, no, just joking. He's being shy. He's just going to bother me at my feet. Are you guys having a good week though? Okay, good. My kids finally start school tomorrow, so they'll be out of my hair. They'll be in somebody else's.
I meant to go into another line, but I forgot enter doesn't do that.
I know. Sometimes it's a little confusing. Ooh, the SAT practice test. I know. That's a long one, isn't it? So if you guys are in SAT prep, that's long. I know. I should have put in there too. On the 4 sections, you probably figured it out too, but you just need to finish each section at a time. So you don't actually have to finish all 4 sections at once. So hopefully if you're in SAT prep, you probably figured that out, but if not, you only have to do that. 1 section at a time. All right, everybody who's almost here, we're still waiting on a couple, but you guys go ahead and get started on the bell work if you haven't already. Make sure you guys are asking me any questions too. Jameson brought it up to my attention that the one of the Nearpods, the maps and remote sensing wasn't working. So I will check that out for you guys after our lesson. All right, so it is 10 o'clock. Let's go ahead and get started. So I'm going to give you guys 2 minutes to finish up on the bell work. So high low. So what do you want to know? So share one high. So something that's really awesome that's going on this week. It does not have to be science related or even school related. And then also one low. okay? Sometimes the lows help us appreciate the highs, right? And something that you have learned this week. All right, so lots of good ones. So hi, you might finish early this week. That's always awesome. Finishing the SAT practice test, don't have a low. Well, that's good. It's always nice to hear. Ooh, first football game this Friday. Awesome. Hi, finishing work or early. Good job. Low, stressing out. I know sometimes the first, couple weeks of school, it's a lot. And so don't stress out too much. Okay. It's not worth it. And you're high. You got to see a friend this week. Awesome. Oh, low. Your dog's really old and sick. I know. I went through that a couple years ago, so I know how that goes. That's not a good thing, right? But we all know it's part of life. Had a nice breakfast today at Capri. Ooh, nice. Capri's by my house. We must be neighbors, or at least the one in Meridian. Something that I learned was the scientific myth. Ooh, yeah, that's a good. It's nice to kind of learn about things, right? Finish your school this week. Yep, it's always a good one. I always feel good too when I finish my work and my grading. Still grading, but that's all right. Good progress, good. Low the workload. I know sometimes it seems like a lot until we get into that routine. Take about 5 more seconds. Make sure you guys are finishing up. And there's our timer. I'll give you 10 more seconds. All right, so I'm just trying to think of my high this week. I guess it's a high and it's a low. My kids are going back to school, which is nice, but also it's sad because I've been home with them all summer. So I guess it can be both, right? Hi, I went to Air Force Museum with your grandpa. Awesome. You learn more about the nature of science. Is that your low? That's all right. Oh, stressed. I know, that's stress. Don't let that take over you guys. Sometimes a little stress is nice, like a little pressure, but sometimes if it's too much, we don't want that. So just know that balance, right? Between a good amount of stress and stress that could affect our health. So we don't want that. Ooh, you got to go boating. Nice. You don't have to do anything on Friday. Getting done early, that's always the best. Different levels of the Earth's crust. Awesome job, you guys. So it's nice to kind of hear things that are going on in your life besides earth science, right? That's one thing I think that's kind of hard about being online is we don't really get to know each other that well. Or at least it's harder for us to get to know each other when we're online. But these little things help us kind of get to know each other. I should probably start putting your names so we maybe could see that. That would be nice. All right, today we're going to talk about experimental design, which is kind of taking more on with the scientific method. So our essential questions. So in every lesson, you guys will have these essential questions. And basically I'm going to be giving you information to answer your essential question by the end of the lesson. So our essential question today is, how can I design a good experiment? Okay. So if you are a scientist, these are the tools that you will need to conduct a great experiment. So our objectives today that we will accomplish, you will be able to design a controlled experiment. We'll talk about what controlled is. I'm sure most of you know, but we'll talk about the importance of it. Also, we will start working on analyzing data to draw conclusions. Okay, so looking at a graph and inferring what that information is. Okay, you guys are going to be experts at that. So this will be an ongoing skill and tool that we will use. Eventually in 11th grade, you guys will take science ISATs. That will be a super important tool that you will use, interpreting, analyzing data. So we'll continue to work on that throughout our years. All right, so good experiment. So what do you think are some characteristics of good experiments? What makes those experiments good? So I'm going to give you guys another 2 minutes to think about this. And we can kind of judge too where we're at and everybody's answering, but we'll take 2 minutes. So some characteristics of good experiments: make a hypothesis, solve it, good. Having the ability to make predictions, great. Hypothesis, idea, plan, experiment, conclusion, great. Ooh, this is a great one. A question that is testable, and we'll talk about that more too. A good experiment is a single variable is tested, awesome, and a control is used, exactly. Hypotheses, yeah, so coming up with that hypothesis, testing it, and hopefully solving it, right? But we know that most science is a process, and we don't solve these problems usually in one experiment. A good experiment can be conducted well if it has a question that can be tested and a solid hypothesis. Good. Characteristics of good experiments are the factors of scientific method: hypothesize, infer, and solve. Good. Tested and succeeded. Yeah, sometimes experiments are based on other experiments, other information. Awesome job. Testable hypotheses. Good. You guys got this. Control group and an experimental group. Very good. A strong hypotheses. Yeah, you guys got it. Scientific method. It's a question or hypothesis that's testable. Amazing. Yep. You guys are doing it. So we're going to talk about all of these things that you're mentioning in your collaboration board. We're going to talk about those testable hypotheses. We're going to talk about planning. We're going to talk about variables and what those are. We're going to talk about data, different types of data. So great job. We have about 5 seconds left. So I want you guys to go ahead and submit. And we will move on. All right, so let's talk about the scientific process. Okay, and what are the steps? What should we be going through? And what are some important takeaways from each step of the scientific method? Okay, well, the first one is we're going to start with a hypothesis. Now, sometimes you might be asked, what does the scientific method start with? Now, sometimes people will mention hypotheses, but often when I say people, it could be like your textbook scientist. It starts with an observation, okay? That observation will lead to a question, and then that question will lead to your hypotheses, right? So what is a hypothesis? A hypothesis is a testable, which a lot of you guys put in that collaboration board. So awesome job. So it's a testable, proposed explanation. One thing I noticed in your collaboration boards is that you didn't put an educated guess. All right. Now, you've probably heard that a lot growing up, that educated guess. But really, we want a testable, proposed explanation. And this is typically going to be based on your prior knowledge, or maybe your experience, maybe data from another experiment. Okay, so just keep that in mind. Again, so previous understanding, background, research, or observations. Again, this must be testable. All right, so your experiment should be able to prove your hypothesis right or wrong. So also when we say testable, we also mean repeatable. Okay, so if another scientist were to take your experiment, they should be able to repeat it, and they should be able to get the same results as you. Okay, so that's another important aspect of your hypothesis and also the experiment overall. So you often are going to see hypotheses written in an if, then, and sometimes because. So if I add 15 milliliters of fertilizer to a plant, then it will grow 20 centimeters a week. Now, in the chat box, I want you guys to tell me, what did you notice about my hypothesis too? So that one that I put, what did you notice? What did you notice about it? So it's testable, right? But what else did you notice about the hypothesis that I said? It was very specific. Yep. So if you are a scientist, hey, you want to make sure those hypotheses are super specific and detailed. And that way it's repeatable. Okay. So if you were to give your hypothesis in your experiment to somebody else, they would be able to repeat it exactly, and they would get the same results. All right, so let's move on. Actually, let me just repeat this because we kind of will go back to this one. So I want you to keep this example in mind. So if I place a plant under UV light, then it will grow at a faster rate than a plant placed under infrared. Okay, so although this one is specific, it's not as specific as the one that I said. All right, so testing our hypotheses. So what do we need to know so that we can properly test our hypotheses in an experiment? So what are my variables? What do I need to keep constant? What materials do I need? And how will I measure outcomes? Jameson, go ahead, answer your question.
So I have a question, of course, but I wrote down the definition for a hypothesis, and I was wondering, so that first sentence in the last slide, I put that as the definition for hypothesis. Is that correct?
You were cutting out. Do you want to maybe turn your video off and then talk? Sometimes your video can kind of lag your internet when you're asking questions. Okay, go ahead. Sorry. So the definition, why don't you say the definition again, and then that way I can know for sure.
I put down a testable proposed explanation for an observation, like the first sentence.
That's perfect. Okay. Yep, that's amazing. Yep, exactly right. Good job. All right, so now we're going to talk about specifically how we test them. So we're going to talk about each specific variable. Okay, so the first variable that we're going to talk about is our independent variable. Now, this variable is going to be manipulated, okay, or changed by the scientists. So this is the variable that you are choosing to change, okay? So the independent variable is the variable that you are choosing to change. So this is always found on the x-axis. So can anybody in the chat box tell me, on this particular graph, what is the x-axis, or what is our independent variable? Is it time, or is it degrees Fahrenheit? It also says in there, right? So what do we think is the independent variable? Good job, Alyssa. It is time. Okay, so time is what we are changing. So if we measure the temperature, okay, oh, sorry, yeah, time would be the independent variable. Okay, so it would look like this. So again, just know that it's what you are changing or what you're adding. And I have a little acronym too for you guys to remember these. All right, the next one is going to be the dependent variable. All right, so the variable that is measured by the scientist. Okay, So its value depends upon the value of the independent variable. So I always remember it depends on the independent variable. Okay, so if the independent variable, okay, that we are manipulating will change what we're measuring. And it's always found on the y-axis, okay, which is right here. And it's our degrees Fahrenheit. And we will practice these because sometimes they can be difficult. But again, for me personally, I just remember the independent variable is what I can change. And the dependent variable is what changes because of what I change, or the independent variable. All right, so we will definitely practice these. All right, so now here's that little acronym that I told you. So think of dry mix. So dry, okay. Actually, dependent variable depends on our independent variable. It's responding and it's on the y-axis. Mix, manipulated variable is the independent variable, and we graph it on the x-axis. All right, you guys, so let's move on. All right, so let's take a little poll. And now we're going to practice. All right, so what is the independent variable? I'm going to read it to you guys, and then I want you to take some time to analyze it, and then we'll talk about it. All right, so a scientist plants 10 corn seeds in 10 pots with good planting soil and places 5 plants under UV light and 5 under infrared light. She then waters each seed with 30 milliliters of water each day and makes sure that all plants receive 12 hours of light. As the plants begin to grow, she records the height of each plant on a daily basis. So what is the independent variable of the experiment? So just take a couple of seconds. I want you guys to answer this, put it in the chat box. Don't do it yet, but I want you to put your answer, A, B, C, D, or E. Don't press send yet. It's okay. Don't press send yet. And in 10 seconds, we're all going to press send so I know. So what is the independent variable? What are we changing? Are we changing the corn seeds, or all the corn seeds the same? Are we changing the type of light, or all types of light the same? Okay, so if we go through and you kind of analyze which one of these are we personally changing, are we personally manipulating? Okay, all right, ready? 3. Make sure your A, B, C, D, or E is in there. What are we manipulating? 3, 2, 1. Press send. Good job, you guys. We are manipulating the type of light. Amazing job. Okay, so The two different types of light are the UV light and the infrared light. Great job. Awesome job, guys. All right, so what do I need to keep constant? Okay, so we just spoke about the independent variable. We spoke about the dependent variable, but we need to make sure that we have constants, that we're controlling all other variables as well. Okay, so we talked about our independent variable. That's the one we manipulate. All other things need to be kept constant. So if you have multiple things changing at once, we won't know which variable is affecting the outcome. So by only changing one thing, and in that case, it was the light, we know, in fact, that everything is held the same and that the light is causing the change in the height of the plants. All right, so here are our constants. We're using the same pots. We're using the same potting soil. We're using the same type of seeds. Now, if we were really getting into it, we would be using seeds that were clones of each other, right? That were genetically the same. Probably not like what we could do. We probably couldn't get genetically identical seeds, but that would be, we want to make sure that we're using the same water, same kind of water, hours of light exposure, temperature, humidity, etc. All of those things are kept the same so that we know the light is the one causing the change. All right, so any questions so far? Are we good? You guys want to give me a thumbs up? Pretty good. Let me scroll through your faces. All right, good. Nice, perfect. If you guys have questions, make sure you put them in the chat box. All right, so let's again. So what do you think are some of the things I would need to keep constant in the temperature experiment? So what I'm going to do for you guys, you don't have to scroll back. I'm going to scroll back to the temperature one. Remember the one we spoke about right here? Okay, so what are some variables you guys think that we would need to keep constant? Okay, let me go back even more because, right, that's probably the best one. So here's the hypothesis. So if I measure the temperature throughout the day, time would be the independent variable, okay? So what are some things that you might need to do? What are your constants? Let me go back. Where's the, I thought I put in here the actual experiment. But just think about what are some things you can keep constant. We won't think too much. So we'll do like 30 seconds. Oh, I need to go back and edit that. So go ahead and take 30 seconds and then we'll move on. All right, guys, make sure you go ahead and press submit. There's really not going to be any wrong answers because that experiment wasn't very detailed, was it? All right. So now let's talk about data. So after we go through these experiments and we go through the process, we want to collect data. Okay, so first we need to collect our materials. All right. But really what's important is we need to also have materials that are going to be able to collect our data. So there's two types of data or two types of observation that we will make in experiments. The first one is qualitative observations. So these are things that you can see with your five senses: sight, touch, taste, sound, and smell. Now in science, we don't usually taste things, but that is something that you could do. Maybe if we're doing an experiment with food, you would taste it. But just know that these are going to be your qualities: red, blue, loud, okay, salty, sweet. So those are all qualitative. The second type is going to be quantitative. So these are things that have a value, a number, and we measure this with tools: a ruler, okay, maybe a beaker, a thermometer, a scale. Okay, so these are things that have a quantity or a number attached to them. So you should easily be able to tell the difference between qualitative observations and quantitative observations, because quantitative observations will have a number. So super important to know that. All right, you guys, so let's move on. So before you guys answer this, okay, I'm gonna break you guys out into groups to answer. Actually, just joking, we're not there yet. So answer this poll together. I also want you guys to put it in the chat box. In 10 seconds, we're all gonna press send at the same time. So what type of observation is this? There are 27 students in our class. So qualitative or quantitative. So in 5, 4, 3, 2, 1, go ahead and press send. Awesome job. You guys got it. It is a quantitative. Now, does anybody want to unmute themselves, or even in the chat box, tell me, how did you know that this was quantitative? Go ahead, Andrew. How did you know that it was quantitative? Go ahead and unmute yourself.
Well, one is observation. So you use sight, touch, taste, smell, sound, and sound.
Good.
And the other one, so if there's 27 students, what are you exactly using? You're using not all five senses, using just sight. And then you're using tools.
And then you're also doing what? What's associated? We have that
27 number.
We have that number. Good. Awesome job, Andrew. Yep, you guys got it. All right, so control group. So what is a control group? So this is used for comparison, okay? And it's only used in some experiments. So sometimes you'll be asked, what are the control group or the experimental group? Your experimental group will be the one with that independent variable. And just know not all experiments have that control group. But if we do have a control group, it's used for a comparison. So the example that's given here is that pharmaceutical companies will use a control group. They'll also use experimental groups. So that control group, they're given what we call a placebo, which actually is no medication at all, okay? And they're the ones that will compare to the experimental groups. So sometimes you have control groups and experiments besides these pharmaceutical experiments, but just know that not all experiments have that control group. Okay, so what do we want to know about our control group? We want to know that it's used for comparison with the experimental group. And those experimental groups are the ones with the changing independent variables. All right. Any questions on the control group? No? All right. So let's review. All right. So now here is one. I'm going to break you guys into your group. So I'm going to give you guys 5 minutes to answer these questions in a group. Then you're going to answer 5 questions. And then at the end of the 5 questions, hold on, I'm just going to go ahead so you guys can see. You're going to answer all 5 of those. I'm going to go through so you guys can. And then we'll come back and do the last evaluation questions together. Okay, so I'm going to break you guys into your groups now. And you have 5 minutes to do these together. And I'm creating them right now so that you guys, all right. So make sure you guys are unmuting yourselves. If you guys have issues with lagging, you can turn off your video, but please make sure that everyone is talking in the group. That's the most important. All right. So go ahead and get started.
With the matching.
Yeah, you guys are starting with the matching. So one of you might want to share. Let me actually give you guys permission to share. I might have to go back to the main room, but let's see. You guys can share that way. You can, okay, come on, close. If that's easier, if you want to share your screen while you're doing the matching. Okay.
Okay.
Perfect. And yeah, and then you're doing those 5 questions too. And then just call me if you need help. All right. Okay. Sounds good.
Which one should we do first?
All right, so that's all of those.
I also allowed you guys to screen share. So if you want to screen share, that's something that you guys can do.
Okay.
Sound good? It might be easier if you are doing the matching.
Okay.
How are we doing,
Hi.
guys? I enabled screen sharing. So if you want to share your screen, you can do that too. If you know how to do that. If you're doing,
I'm reading off all these notes I have. Like, oh, I filled my whole page. My whole page is just filled with the whole notes.
good. That means you're learning and then you have it to
Yeah.
reference, right?
When I have to go do both the Nearpod and the test that I'm definitely gonna do today, so I only have 2 things tomorrow.
Good. Awesome job. All right. So yeah, so just finish up on your matching and your questions. And then you can always call me back if you need me to.
Okay.
Oh, perfect. Yep. You guys got it. Awesome job. How are we doing in here, guys? You guys doing all right?
Yeah, we're good. We're just matching the stuff.
Okay, perfect. So I enabled screen sharing. So if you guys want to share, one of you wants to share your screen, you can definitely do that.
Okay, thank you.
You're welcome. And I will see you guys back in about a minute.
Okay.
on this graph, okay. On this graph, numbers of potatoes is the blank variable. So I guess it's my turn. So
All right.
All
You
right.
guys needed some help?
Yeah, so we were wondering if you wanted us to do the quiz.
I do. Yep.
Okay.
Go ahead and finish out the quiz. And
All
let's
right.
see. You only have like a couple seconds left. So if you don't finish, you can always go back and finish that up too.
All right.
Sounds good.
Okay, this should be a breeze.
Perfect.
All right, which of the following is not a good hypothesis? Getting fewer than 6 hours of sleep has a negative effect on.
All right, guys, we'll wait for everybody. Did you guys get finished up on everything?
Yes, we did.
Okay,
Yeah.
perfect. Good. So it was enough time. Everybody should be coming back. All right, you guys. So hopefully everybody finished up. If you didn't, just make sure you go back and finish up those questions together, and I will check those out later. But the last thing I want you guys to do is we'll just kind of do a little bit of a check-in, and let's just evaluate kind of where we're at with the scientific method. Well, that's not the right, I don't even know how that question got in there. Do not answer that question. Completely wrong class. That is so, don't answer that, please. I feel like I've been hijacked. All right, our exit ticket for today is, what is one thing you learned today? It could be anything, really. Hopefully it's science related and the scientific method. And then after you are done, you are free to log off. And then I will see you guys on Monday. And then as always, guys, if you have questions about anything, please let me know. And then I know there's an issue with one of the Nearpods, so I'm going to go in and check that out as well. All right, so once you guys are done, like I said, you are free to log off, and I will see you later. Yeah, you guys have a great rest of your week. Hopefully you're not too stressed out. Don't stress out about stuff. I saw lots of stressing on that collaboration board. Let's limit our stress. We don't need that in our lives, right? All right, you guys, I will see you later. Bye.
Mommy.